Welcome back all of you. In the last lecture, we have seen the different possibilities of triaxial testing and what are the different type of tests that we can execute in a triaxial cell. In today's lecture, we will learn how to interpret these test results. As we have seen, there are three major type of triaxial testing: unconsolidated undrained UU, CU consolidated undrained, and CD consolidated drained. In today's lecture, we will see the interpretation of unconsolidated undrained test. So, it is UU test. We have already discussed that UU test is a quick test and it is completed mostly in 10 to 20 minutes. You may refer to Holtz and Kovacs book because much of these discussions I am referring to that. It is also known as quick test. Let us first see what are the different the stress condition in the soil sample for UU test. The initial condition pertains to the soil sample once it is sampled from the field. So, let us say that this is the sample soil which need to be tested for UU. We have already discussed about the effect of sampling in our previous lecture. And what did we discuss there? What we have told is that during sampling, the confinement and the overburden stresses gets released. And we have tried to compute what is the pore water pressure that would be there in the soil specimen. Now, that information becomes quite handy for this particular lecture, because when you sample, the stresses are released and hence we have the lateral as well as axial stresses to be 0, and this is immediately after sampling. Now, what is the pore water pressure? Whether pore water pressure will be 0 or it will be something else. We have already seen for a typical normally consolidated case with a value of 0.5. In our previous lecture, we have seen the final pore water pressure will be always less than the pore water pressure when it was there in the field. That means it tends to become negative. So, here I am considering it to be negative because it is lesser than the initial condition. Due to release of the confinement, the pore water pressure tends to be negative. Now, this is represented as minus UR. So, this is negative pressure after sampling, and this UR is known as residual pore pressure. Okay. So, this UR or the negative UR is instrumental in preserving the sample or holding the sample intact. This also we have discussed in the previous lecture. Now, this UR, what will be its value? It will be a function of initial state, and initial state, when I say, it also pertains to W, that is the gravimetric water content, and E, which is the void ratio. It is also a function of a third quantity which we have already seen, which is stress history, because A value is dependent on stress history. So, what will be the effective stress? Total stress minus pore water pressure. So, we have sigma dash 3 naught, that is all round stress will be equal to UR. So, this is the initial condition of the sample. Now, this sample need to be saturated first. So, the very first stage in triaxial testing is saturation, and we use the B parameter. We have seen all these things. Let us say that the sample is fully saturated now. So, the next stage is confinement. So, what will be the stress changes that happens to the sample? So, to the sample we apply the cell pressure sigma 3. Now, because of this, what happens? The pore water pressure would change, because in UU test it is under undrained condition. So, pore water pressure will be minus UR was there, the residual pressure pore water pressure which was already there in the sample. It was already there, so minus UR plus UC. Now this plus UC comes from where? Now this plus UC is comes from because of the cell pressure application. So this the pore water pressure after the application of confinement is minus UR plus delta UC. Now delta UC comes from where? It is because it is associated with the application of cell pressure. So we need to use the pore water pressure equation, so it will give the same value. What is the pore water pressure equation? That is delta U is equal to B into delta sigma 3 plus A into delta sigma 1 minus delta sigma 3. So I am just writing this just to make you understand how handy the pore water pressure equation is. Now in this case delta sigma 1, so this part goes, so we are left with delta U is equal to B into delta sigma 3, and B can be considered equal to 1 because we have fully saturated. So delta U is equal to delta sigma 3. So that is how it comes here. So minus UR plus sigma 3, and sigma 3 is the confinement applied. So what will be the effective pressure? Effective pressure will be sigma 3 minus UR plus sigma 3, that is equal to sigma 3 and sigma 3 gets cancelled off, it will be UR. So the effective stress is UR now. So then comes the shearing stage. So without opening the drainage wall, stress is applied, or the axial load or the axial stress is applied, and that is equal to delta sigma, which is the deviatoric stress component that causes failure. And what will be the pore water pressure? So it will be minus UR plus sigma 3 plus minus delta U. Now this delta U is because of the result of delta sigma. Now why it is plus minus delta U? Because we have already seen that for depending upon the stress history, whether it is a normally consolidated or an over consolidated soil, in terms of volume change during shearing, over consolidated soil will tend to dilate and a normally consolidated soil tend to compress. Now it is an undrained condition, so we have seen that accordingly the pore water pressure would change. So a dilating soil will have negative pore water, or pore water pressure will start reducing and tend towards negative, whereas a compressing soil like NC, that will have positive pore water pressure. So that is the reason why we have plus minus delta U. So it is simple then, the effective stress will be this sigma 3 plus delta sigma minus this one, this quantity. So that is what is shown here. So ultimately here it will be sigma 3 gets cancelled off, UR plus minus delta U, and similarly here also sigma 3 gets cancelled off, so delta sigma plus UR plus minus delta U. So this is the different stages of UU test and what will be the kind of stresses in the soil sample. Now how do we do the UU test? We need to have at least 3 identical samples. So for example, we want to find out what is the undrained strength at a particular depth. Now from that particular depth we take it, we sample, or during subsurface investigation we collect undisturbed samples which corresponds to that particular point. So at least 3 identical samples are needed. So that is used for determining the undrained shear strength. Now all the 3 samples are assumed to have initial state same, that is dry unit weight, water content, and hence the void ratio. Now this is not really practically possible to have exactly same, but we assume that these 3 identical samples are in fact identical in terms of its initial state, because this assumption is very important for understanding the strength. The moment it changes, the strength aspect also changes. Now this is the condition. Let us say these are the 3 identical samples to which we are applying 3 cell pressures, sigma 3.1 first, then sigma 3.2 and sigma 3.3, where sigma 3.1 is less than sigma 3.2 less than sigma 3.3. Now at failure, I am not going to the details of it. After the test is conducted, we have the failure stresses now, which is deviatoric stress, which is sigma 11 minus sigma 31 or sigma 13 minus sigma 33. So this is the deviatoric stress at failure. So this is at failure condition, and we have already discussed that there is no need of measuring pore water pressure. We will come to know in a few slides like why this is valid, but still I am marking that the pore water pressure is U1, U2 and U3. So what happens, like if you plot these results like sigma 1 minus sigma 3 versus axial strain epsilon A, there is something interesting what comes out, that is the final deviatoric stress at failure, it comes out to be more or less same. So for saturated soil, even though the confining stresses are different, we have the same almost identical magnitudes of deviatoric stress at failure. Now this has some important significance. There is no change in the initial effective stress condition in the confining stage. Now why this is so? Why we are having such a result? Like there is no change in deviatoric stress even though the cell pressure is increased. We know that we are not consolidating the sample. It is an unconsolidated test, hence there is no change in the initial state of the sample. Only when you consolidate, there will be changes in void ratio or water content, and hence the initial effective stress condition changes, and we know that the strength of the sample is dependent on effective stress conditions. So here there is no such change, and hence the deviatoric stress at failure is more or less same. The soil sample is mounted and total stress applied under undrained condition. So there is no scope for consolidation in UU test. So what is the net result of this? What do you mean by same deviatoric stress, and how does it translate to failure envelope? So that is what we will see here, is a failure envelope for UU test. Here it is tau versus sigma plot, and now we will see that sets of experimental results we have plotted in terms of Morse circle. Now deviatoric stress same means, it means sigma 11 minus sigma 31 is same. So you have same diameter Morse circle. So this is the first one, this is second one, and this is third one. All of them have same diameter. So this means what is changing then? Sigma 31, this is the initial point, is changing because there is a Morse circle. Now sigma 32 has been increased. Now it starts from here, but the deviatoric stress or the diameter of the Morse circle remains same. Same with the third case. Now for the first one, we have the pore water pressure measurement. If you find out the effective stress circle, how will you do? Just minus the pore water pressure, we will get the effective stress circle. Now what is happening? There are 3 total stress Morse circles, but there is only one effective stress circle. So that is what we see from this particular figure. So what will be the failure envelope? The failure envelope is basically tangential to the Morse circle. Now here the only possibility of tangential this thing is a horizontal line. So this horizontal line represents the Morse failure envelope, okay, but this is very specific to undrained condition. So this is purely a total stress analysis. There is no effective stress envelope. There is effective stress circle, but there is no effective stress envelope. When will you say that you have an effective stress envelope? Only when we have tau versus sigma, and if there is multiple effective stress, then one can draw a failure envelope. But here 3 total stress circles have resulted in only one effective stress circle. So one cannot draw a Morse circle failure envelope. We can draw Morse failure envelope only if we know what is the angle of internal friction. Okay. So, there is effectively no effective stress envelope possible from UU test, and some of you would have understood this concepts very well during your UG, but it is normally observed that these aspects are not fully appreciated during your UG learning. So, it is very important to understand what is the significance of UU. So, that is why I am taking time and explaining it in detail. For some, this may not be needed. Okay. So, Morse circle at failure have same diameter, I have already explained. Only one effective Morse circle at failure, I have explained what is the reason, because there is a corresponding increase in the pore water pressure. For sigma 31 there is U1, sigma 32 proportionally it is increasing, so for by U2, sigma 33 proportionally it is increasing to U3. So, there is no scope for any sort of changes, not possible to get more Coulomb failure envelope in terms of effective stress. So, there is no use of U measurement in UU test. Now, possibly you will appreciate this point, why there is no need of pore water pressure measurement. Even if you measure, you are not going to get any effective stress envelope. This test gives undrained shear strength, exclusively the value of SU. Now, there are several textbooks in which you will find it is denoted as undrained cohesion. In fact, if you understand this aspect, that from UU test what you get is undrained shear strength, there is no harm even if you use the term undrained cohesion, because it is very difficult to comment on the kind of cohesion that exists. So, here it is in general, it is better to use the terminology undrained shear strength, and which is represented by SU. And this SU is what you obtain from UU test, and which is used for specific design applications. So, SU is what? SU is equal to QU, which is equal to sigma 1 minus sigma 3 by 2. So, this we need to get the radius of the Morse circle, and that is the Morse failure envelope. So, sigma 1 minus sigma 3 by 2. Effective stress at failure is independent of total cell pressure applied. We have seen there is no effect of sigma 31, sigma 32, sigma 33. These statements denotes the same thing, but why I am stressing these statements again and again is that these are different ways by which you tell the same thing. So, that you need to understand it carefully. Since it is completely undrained, the friction cannot be mobilized. So, there is no concept of phi coming into picture. So, total stress envelope is phi equal to 0. Hence, this test is also known as phi equal to 0 test. So, undrained shear strength is independent of normal stress, which is constant limiting shear strength. This undrained shear strength SU is known as constant limiting shear strength. Now, what do you mean by this statement? At various normal stresses, you have the same value of SU. So, that is why it is independent of normal stress. Now, this part many of you would have understood, but what is the significance of this phi equal to 0 failure envelope? Now, this condition is used by Tresca failure criterion, or it is known as maximum shear stress theory, because you are considering the maximum shear stress point. In fact, the soil, when you consider the effective stress conditions or various other triaxial test results, you will see that it does not fail at maximum shear stress conditions. Only for undrained condition, the failure is associated with maximum shear stress that emerges in the soil. So, Tresca yield criteria for soil is based on the undrained shear strength SU. So, sigma minus sigma 3 is equal to 2 SU. So, when the stress condition approaches SU, it is found that the soil would yield. For dealing with any undrained shear problem in soil mechanics, the Tresca criterion is used. This equation is valid for total stresses even when the shear strength is governed by effective stresses. Why? What is the importance of this statement? This equation means sigma 1 minus sigma 3. We know that even though there is pore water pressure or not, whether it is effective stress condition or not, sigma 1 minus sigma 3 equal to 2 into SU will be valid. we know that shear strength of the soil is exclusively determined by its effective stress condition. So, even if I write sigma 1 minus sigma 3, that is equal to sigma 1 dash minus sigma 3 dash. So, it is not violating in any form that when whatever our understanding is that the shear strength of the soil is exclusively dependent on effective stress condition. So, this it does not violate this. For an expected undrained condition, that is a short term response, shear strength of the soil is equated to SU. What we need to understand is that if we know that we are doing a short term analysis and the conditions are undrained, it is that we equate the strength of the soil to this undrained shear strength SU. This is more relevant for end of construction phase where undrained condition may be relevant. SU is dependent on initial condition, we have already seen this, void ratio and water content, hence it is not a fundamental soil property. It exhibits a wide variability. You can see that it is approximately 0 for soft clays, 2 megapascal range for stiff soils depending on the initial state. Now, if you are considering the actual field problems, then SU at a site is normalized with respect to effective overburden pressure, which is equal to sigma dash V naught. That is effective overburden pressure. Why? Because as the overburden pressure increases, we know that the void ratio or the water content would change. Now, we will get multiple values of SU, which was influenced by the overburden conditions. So, that is why it is normalized with respect to effective overburden pressure, so that comparison will be easier. So, this normalization with respect to sigma dash V naught helps in better comparison of data. Now, we have talked, it is quite understood that whatever we are discussing now is with respect to saturated soil. Now, what would happen if there is improper saturation for the soil sample? So, that is what we will see in this slide. Partial saturation results in air present in the volume. So, this is also known to us. When sigma 3 is applied, now when there is air present, what will happen? As you apply the sigma 3, air tends to dissolve into the water and hence the void tends to close. So, what we are doing for an expected undrained test, there is going to be a volume change. Now, this is against what we want, because for a truly undrained condition we expect that there is no volume change, but if there is presence of air, then volume change is bound to happen. So, if you see that this is the cell pressure application, so if air is present, now I will write this condition: if air is present, what will happen? There will be volume change. So, there is an unexpected or hidden volume change in an undrained test where we assume that there is no volume change. So, volume change occurs under undrained condition, unlike the saturated case. This alters the initial state of the soil. Now, once the initial state alters, that will impact the strength of the soil and the initial effective stress condition. Why? Because there has already been a volume change. Now, the deviatoric stress which was same at failure for a saturated system, now it will increase with sigma 3, because as sigma 3 increases, the amount of volume closure also increases till the entire air voids is removed. So, that will influence the deviatoric stress at failure, which keeps increasing. So, saturation will increase with degrees in E as the voids close. When the air gets dissolved into the water or expelled out, what will happen? The saturation also will increase. Now, as the volume change increases, saturation also increases, and at some sigma 3, saturation approaches the value of 1 and the results will be then close to a typical UU test. So, what will happen? As the confinement goes on increasing, the amount of void closure also increases, saturation increases, at some point of time saturation approaches 1. So, then the results what you will be getting will be identical to the saturated UU test. So that is the impact of saturation. Let us see what is happening. Now this is sigma 3(1) where some of the voids gets closed because of the expulsion of air. Sigma 3(2) again some volume closes, and you can see that the deviatoric stress keeps on increasing. Now deviatoric stress keeps on increasing means diameter of the Morse circle keeps on increasing. Now up to sigma 3(4) there is a increase in the Morse circle. Now beyond that the Morse circle diameter more or less remains constant. So what would have happened? Now this is a typical test of UU, but the soil sample was not initially saturated. So instead of getting a horizontal failure envelope, you are getting a curved failure envelope, and at some confining stress it becomes same as phi u equal to 0. So this is the value of the undrained shear strength. So what is this initial portion? This initial portion is mainly due to the partial saturation or improper saturation. So here beyond this line it is SR less than 100%, and for this it is SR equal to 100%. So from here on it is 100% saturation, and hence we get the same failure envelope phi u equal to 0. So sigma 3(1) to sigma 3(4) causes volume change due to confinement. Beyond sigma 3(4) results are identical to typical UU test. Sigma d changes with sigma 3, and beyond sigma 3(4) sigma d remains same. So this is again I have redrawn it here to show you important aspect which we have to keep in mind when we know that we are conducting UU test. So if one get such a pattern of Morse circle, or maybe most of the time what we do is we have only 3 or 4 repetitions or identical samples tested. So if it is 3 or 4, then what happens is 1, 2, 3 we will be getting a curved failure envelope, but we know that it is a UU test result. So if we know it is UU test, then we know that we are not expected to get a curved failure envelope, it has to be a horizontal failure envelope. So unless we appreciate this point, when you go through a test report, then it is difficult to make out this point. So always keep in mind that if it is a UU test, then phi is equal to 0. If you find that there is a curved failure envelope which is tangential to the Morse circle, then the problem lies with the saturation. So this is what I told, curved failure envelope is not expected. It may be due to improper saturation. So we need to discard the initial portion, either repeat the test or discard the initial portion, or take an average value of SU. And definitely if you are considering the initial portion where it is curved, this particular portion, if you are averaging it out, definitely you will be having a lesser value of SU. So it is always better to investigate why and what has caused a curved failure envelope in UU test. Now comparison of UU test for NC and OC state. So you can see that tau versus sigma is a total stress circle, phi equal to 0. Now because of positive water pressure, you will have effective stress circle shifted towards the left, and this is a typical case of NC state, that is normally consolidated soil. Normally consolidated soil during shearing will have positive water pressure. So this will shift the effective stress circle towards left, and the same for over consolidated soil, U will tend to be negative, and hence the effective stress circle shifts rightward. So these are the two comparisons how the stress history would influence the UU test results. Now we have almost finished the UU test discussion and its interpretation. We will see what happens in unconfined compressive strength. Now this is a special case of UU test, that is why I am discussing along with UU test. So it is a special case where sigma 3 is equal to 0. So this is the condition where sigma 3 is equal to 0 and sigma 1 is the unconfined compressive strength. This is what I meant. So instead of starting from somewhere here, The starting point is at sigma 3 equal to 0, and this diameter is sigma 1 minus 0, that gives the unconfined compressive strength, but everything else remains the same. We have the same undrained shear strength. So, UCS is equal to sigma 1 minus sigma 3, and SU is equal to sigma 1 minus sigma 3 by 2, rather sigma 1 by 2 in this particular case. Specimen to be homogeneous and intact. Soil must be fine grained and negative U excess, I mean to say the negative residual pore water pressure is there, otherwise this soil will not remain intact. So, it is applicable, UCS is applicable for these situations. Loading should be quick to maintain undrained condition, because this is considered to be an undrained test. So, SU obtained from UCS and UU are same for identical soil samples and conditions. So, there are cases where you may not get identical test results of UCS and UU depending upon specific conditions, but in practice or in general we always consider UCS test and UU test for the same initial state of the sample will be more or less identical. Stress condition in UCS same as that of UU test. Let us see that this is the initial condition UR, and this same as that of whatever we have discussed. Now, axial loading stage, there is no confinement, so it is directly axial loading stage. We apply delta sigma, and that is nothing but sigma 1. So, what will be minus UR plus minus delta U, which is coming from delta sigma. Why? This is considered to be an undrained test. So, please do not forget that particular aspect. You will be wondering where is the pore water pressure coming from, but it is there because it is a quick loading test. So, what is the effective stress condition? It is UR plus minus delta U. You can see that if you compare this effective stress with that of UU, you will see that this is same. So, that means that we are going to get the same strength. Now, what is the relevance of undrained shear strength? It is relevant for cases where loading is rapid and undrained condition prevails. SU, which is the undrained shear strength. So, change in total stress during construction. It is not going to influence the whatever is the strength that is available. End of construction is most vulnerable phase where undrained condition and U will be highest. So, UU shear strength is more relevant for such cases when there is end of construction phase. This is very easy to understand because we have already discussed this total stress variation with time in one of our previous lectures. So, this there quick construction of embankment over a soft clay, it gives SU. Now, this SU is there for a particular state of the soil sample, and that is not going to change with the construction sequence, that remains the same. Only aspect is if it is a quick construction, then the undrained condition prevails and SU becomes active or SU becomes more prominent. Short term load capacity of piles is also based on the total stress analysis where SU is relevant. I hope you remember in foundation design for piles there is a short term analysis where we consider that the soil exhibit an undrained behavior. In that case, what we have is the undrained shear strength SU. So, for designing of piles or determining the pile load capacity, one need to know the value of SU. So, that is what is shown here. Undrained modulus, now if you want to determine the elastic settlement or the quick settlement, what that happens immediately after loading, we need to have what is known as undrained modulus. It may be initial or secant modulus. It is obtained from UU test and used for determining the immediate settlement. So, that is all about the interpretation of UU and UCS. So, let us try to summarize what we have learned in this lecture. UU test is a quick test. Pore water pressure is not monitored and measured, the reasons we have stated. Sampling of soil in the field induce negative residual pore water pressure that holds the soil intact, that is minus UR. For soil samples with same initial state, different confining stress results in the same magnitude of deviator stress at failure. For identical samples, there is no change in the initial effective stress condition in the confining stage. So, even if you apply sigma 3, that is not going to affect the initial effective stress condition, and that results in the same deviatoric stress. UU and UCS are total stress analysis, which gives undrained shear strength SU. SU is independent of normal stress, and that is what the Tresca criteria is. Tresca criteria is based on SU. SU exhibits wide variability. It depends on initial condition, and it is not considered as a fundamental property of soil. Impact of partial saturation and what is the influence of stress history on UU test result is discussed. UCS is a subset of UU, it is a specific case of UU. Under identical conditions and soil samples, UU and UCS is expected to give same SU. Effective stress at failure is same for UU and UCS for the same or the identical soil sample. End of construction phase, which is essentially a short term undrained, and short term analysis of pile load capacity requires the knowledge of SU. So, that is all for the interpretation of UU test results. In the next lecture, we will continue with the interpretation of other triaxial tests, which is essentially CU and CD. So, that is all for now. Thank you.